Okay, this is the DOS42 classification model builder. It's meant to be a demonstration of the art of the possible when it comes to predictive workloads in Snowflake. The application is comprised of a few of Snowflake's new differentiating features like Snowpark Python stored procedures, Snowflake Cortex ML, and Streamlit for the front end. Again, we're going for the art of the possible here, and we'll be showing some, but certainly not all, of Snowflake's fancy new AI capabilities. And while Streamlit is used as a front end to help the demo flow better and hopefully give folks ideas on what something like this may look like in their own data environment, every operation in the back end is accomplished via direct Snowflake SQL or Snowpark Python functions. And what this means is that data never exits the Snowflake data platform. So what we've got here is a good representation of what it looks like to bring your code to the data versus bringing your data to the code. And this is a relatively new concept that Snowflake has enabled with those aforementioned features, but it's a paradigm shift that comes with really a lot of great benefits. For example, we'll enjoy improved security with data never leaving Snowflake. We can avoid unnecessary ingress or egress costs. We get consolidated billing on both data storage and ML workloads, and have a real opportunity to optimize our ML compute costs by tuning the various knobs that Snowflake provides in terms of warehouse configuration. And finally, there's that old adage that 80% of data science is data wrangling and cleaning, and Snowflake is a data warehouse before anything else, so it's already really great at doing those types of development activities. But now we can take the next step and actually use that data to drive a predictive workload right in the same platform. So there's lots of development efficiencies that should come with that and not having to send data all over the place and into other tools and systems. So let's go ahead and get into the demo. The idea is that I've got some classification use case. So I'm looking to predict a 1 or a 0 or a true-false situation essentially. For example, whether or not a subscriber to a telecom provider is going to churn. So what we do is we make an assumption that some data set exists in Snowflake that has a combination of features that are predictive of a given target variable. So in this case, I've got a data set at the telecom database in the demo schema, in the churn training data table, and that table has a column called churn, and I'm going to tell the application that that column is what I want my target variable to be. So I'll go ahead and submit the selection, and then it's going to fetch all of the columns in that table minus the target variable. And it's going to ask if I want to use those features in order to predict my target variable. So I know that subscriber ID really shouldn't be predictive of churn, so I'm going to go ahead and remove that guy. And then the app's like, okay, is this what you want? I'm like, yes, that is what I want. So I'll confirm my features. And now the idea here is to just kind of walk users through some lightweight feature engineering prompts. Again, we're using Streamlit to do this in the demos case, but you could do that anywhere. You could use SQL, you could use Python to trim the features as needed, or modify the features, or do whatever it is that you want to do from a feature engineering standpoint. So what we're doing here is bubbling up null counts. So machine learning algorithms don't like nulls. It confuses them. So we're just making it really clear if any of our features have a high null count, they would pop out like a sore thumb here, and I would know that I've got to go adjust that upstream. I'm good here, so I'll move on to balance analysis, where a lot of times in a classification use case, you're not going to have in your training data set's not going to be just naturally 50-50 split. But this presents a problem if I've got a really small amount of records that I'm trying to predict, because downstream here in a bit I'm going to split my data set into a 80 training set and a 20% testing set, and I'm going to run into issues because there's just such a few amount of records in the positive class. So we can do this process known as upsampling to balance the data set. And so in the background, all that's happening is I'm running a Snowpark Python stored procedure that uses the SMOTE algorithm to upsample my data set, and then you can see that it wrote the data set back to a new distinct Snowflake table. I don't necessarily have to do that, but it makes it convenient for me to be able to reference it later and work with the data and see the data and materialize it in some way so I can see what's going on. And again, it all stays within the Snowflake ecosystem, so it's super simple for a developer to work with. And so now I've got this data set that's kind of ready, for my purposes to be plugged into a model and train a model. And so the next really cool thing that Snowflake has done is they've got various options for us to do that. They've got their new kind of Cortex suite of AI features where they've got LLMs, and they've got all sorts of different predictive capabilities when it comes to Cortex. One of those is the Cortex classifier. So it's basically a first-party object that I can create. I essentially just tell that first-party object what data set I want to train the data on and what I'm trying to predict, and it kind of takes care of the rest. Alternatively, if I've already got scikit learn experience, or I've already got a model up and running somewhere, there's nothing stopping me from porting that straight into Snowflake in the form of Snowpark stored procedures and leveraging that's already in use. So I could do either. I'm going to use, for the sake of the demo, I'm going to use the Cortex model. So I'm gonna run that guy, and in the background what's happening is I'm essentially just running SQL that says create a Snowflake ML classifier. I give it a name, and I tell it the data that I want to train it on, which is this upsampled training data. Well, in fact, I scaled the data before, so we just do another Snowpark Python procedure to scale the data using a standard scaler before we hand it to the model for training. And then what we do is we just spit out sort of the general stats around that model so that I can, as a developer or a data scientist, I can make a decision on if the model is good enough for use. So in this case, these numbers are pretty good, so I feel good about it. I'll use this model going forward. I'll give it some data to predict on. But you can see sort of the information that's readily available for these Cortex models, and I'll show in a bit how we get that information. It's really, really easy. So now I'll go ahead and run my predictions here. So again, this should speak to sort of the simplicity and the advantages of having everything in one platform. At this point now, I just have to give the model something. I just have to give it data that it's never seen before. So again, I can just go through this kind of flow where I've got a database, a schema, and a table that holds this data that the model's never seen before. I'll submit the selections, and in the background, I just run a SQL statement to say, hey, I want this model to predict, and I give it an input arg of the data to predict on, and then it spits out its predictions, and I can work with that output to make something actionable. So in this case, I've just kind of built kind of an aha moment, if you will, where it's okay, this new data set has an 8.9% predicted churn rate, and these are the individuals that we think are going to churn. This is obviously just demo data. It's not meant to be real people, but the idea is that I would take this data set and I would send it off to the CSAT team, or I'd make it available in a downstream BI tool for someone to go act on and say, hey, we believe that this person, for example, has a 94% chance of churning. Let's reach out to them proactively and figure out what we can do to retain that customer. So that is the demo in a nutshell. I wanted to just quickly kind of zoom out and look a little bit at some of the things that have built in the background just to tie it all together. So we'll use a notebook just to show that. So if I were to run this show Snowflake ML classification command, you can see that it's going to show me that I've got two models in my context. The app model is the one that was just built by the application, and kind of just showing that this thing exists and it's a first-party object. And then this is what it looks like to just get those metrics that I mentioned before. So you just call these kind of helper methods, and it spits out kind of what you asked for. In this case, it's all the evaluation metrics, but there's one for the confusion matrix. And then when I want to run a prediction, you just call a predict and hand it in the data set that you want it to predict on. I also talked about kind of this idea of keeping everything under one roof, and so you can see that as the application worked through kind of those pages, it just was saving various data sets to this single database and schema. So anytime that we were basically pressing a button, we were just materializing some data somewhere. Again, that's not a requirement, but it does make it easy to see what I'm doing in real time. So at first we got a data set from some other database and schema, but we pulled it in, and then we upsampled the data first. That was when we went to 50/50. And then before we built and trained the model, we scaled that same data. That upsampled data was scaled. It was then handed to the model. And then later we said, okay, well, here's a new data set that you've never seen before in the telecom demo schema. And then we handed it to the model, and it spat out this prediction output. And so as a developer, that's really nice because everything was under one roof. I don't have to think a lot about where the data is going, what's happening, am I losing columns en route. It's all very simple. It's all under one roof. You couple that with Snowflake's new notebook features, and you can really be efficient in your development workflow. to get this done. So that's essentially the demo. Please reach out to DOS42 if you have any questions, and thanks for the time.